Okay, welcome back folks, and sorry for the delay there, and hopefully we can kind of pick back up. We were on problem 3 before we left, and what we said on this one, we were going to need to use the quadratic formula, which calls for us saying if we have ax squared plus bx plus c equals 0, then you have the solution to this would be x equals negative b plus or minus square root the b squared minus 4ac all over 2a. Okay, so taking a look at this now, what actually happens? Well, from this point forward, we can find A, B, and C and kind of move forward from there. So let's see what happens in this case. Well, we have our A value equals 3. Our B value, which is tricky, notice there's a plus B, and we have negative 10, but this can be rewritten as plus negative 10 times x, and so that means b equals negative 10, and our c value is equal to 2 because we have that plus 2 sitting right there. Okay, so moving forward from this point, what actually happens? Well, you get x equals negative b, so it goes negative negative 10 plus or minus the square root of b squared, so you get negative 10 squared, minus 4 times a times c. Well, a is 3 and c is 2. And then what happens? This is all over 2 times whatever a is. Well, our a value is 3, so we'll put a 3 right there. Okay, so simplifying this, what actually happens? Well, notice this gives us negative negative 10 makes 10. Plus or minus, this is the square root of 100 minus, so this would be 1224. So this portion right here is going to be 24. And 100 minus 24 is 76. Okay, and we get a 6 right there. And so what this means is we have two solutions. We have x equals, and you can simplify this more if need be, but it's not too bad right now. And if you want to see it simplified more, just let me know and I'll be happy to help you out there. So this is 10 plus the square root of 76 and 10 minus the square root of 76 all over 6. Okay. So once again, sorry for the inconvenience of having to stop and start it back up, but hopefully that makes sense on this one and you can see how it's finished off. Alright, so moving forward, let's start factoring some things. In this case, if we want to factor the following couple of expressions, we have 5x cubed minus 40. Well, first things first, you can see that that has a 5 involved in both of those factors, so you can write this as 5 times the quantity x cubed minus 8. And in the second case, we'll get to that in a second. So what do we do here? Well, you can recognize that this is another scenario of a cubed minus b cubed, which is a minus b, and then a squared plus ab plus b squared. And how do we know that? Well, 8 is 2 cubed. So this is 5 times, goes x minus 2. And then we'll get x squared plus x times 2. That's a 2, don't let your eyes fool you. And then plus 2 squared. And so if we were to simplify this all the way down, what actually happens? This thing becomes just 5 x minus 2 and it goes x squared plus 2x plus 4. Okay, so hopefully that makes sense on that part. And in the next part, a little bit different. You have multiple terms, so what we can do is you can do this thing called grouping. And what we'll do is we'll group the first two. So you go x cubed plus 5x squared. And then in the second case, we'll factor out a minus sign, and then we'll get 6x. And then when you have to distribute that minus sign back, that makes this a plus in that term there. And so now, moving forward from this part, we can factor out an x squared of the first. So you get this is x squared, and then you get x plus 5 minus, and then we can factor out a 6, and then we have x plus 5. Okay, and then, so what does this equal? This is equal to x squared minus 6 times x plus 5. And you can leave it like that, or if you wanted to get fancy with it, remember the difference of squares, so we just take the square root of that last term. So this is x minus the square root of 6, and then x plus the square root of 6, and then x plus 5 if need be, right? But this way we factored out that cubic. And working in the other direction, we can actually expand expressions. And what you can think about is when you're expanding, you're going to take each term times that second whole set. So what do I mean by that? Well, this means we'll have x squared times the x squared minus 6x minus 5. And then we'll have to do plus 4x times x squared minus 6x minus 5. And then minus 3 times x squared minus 6x minus 5. So what does that mean? Well, in our first case, we'll get x to the 4th minus 6x cubed minus 5x squared. In our second case, we'll get plus 4x cubed minus 24x squared minus 20x. In our third case, minus 3x squared plus 18x minus 15. So this makes x to the 4th, there's only one of those. So you have a negative 6x cubed, a plus 4x cubed, and that's it for the x cubed. So that should make negative 2x cubed. Now for the squares, we'll have a negative 5x squared and a negative 24x squared and a negative 3x squared. So that makes negative, negative, negative. That's going to be negative 8x squared plus another negative 24x squared makes negative 32x squared. Okay, then we have a negative 20x. So I'll double underline that, I guess. And then we have a plus 18x. That makes another negative 2x. And then last but certainly not least, we finish with a negative 15. And notice that gives us everything that we've ever wanted right there, an expanded polynomial. Okay, questions on that? So without any questions, we'll move forward into inequalities now. So we've solved equations, we've factored, we've expanded. Now it's time to actually solve some inequalities and write our answers in interval notation. So in the first one, you see fractions once again, so we can deal with that. There's an easy way to handle that. And that way will be to multiply by that least common denominator. And we don't have to flip it because we have a positive number that we're going to multiply by. And so we're going to multiply both sides of this by 15. It doesn't change the direction of the inequality. So when you go 15 times 1/3, notice that makes 5x. But 15 times negative 1 makes negative 15. So this is greater than or equal to, when we take 15 times the 3/5, notice the 15 and 5 will cancel, make 3. And so you'll have 9x up top there. And then 15 times 2 makes 30, so plus 30. Now what? Well, you want to get the x's on one side. I'd suggest getting them on the right-hand side because you don't have to divide by a negative and worry about flipping inequalities in that case. So if you take the, we're going to move the 5x over to this side, and we're going to move the 30 over to this side. So notice, what does that make? That makes negative 45 on the one side is greater than or equal to 9x minus 5x makes 4x. So all of a sudden, what do we have? Well, we have, when we divide both sides by 4, inequality stays the same in terms of sides. So you get negative 45 over 4 is greater than or equal to x. And so if we were to write our answer in interval notation, notice that means x has to be a smaller number than that. So we can go all the way to negative infinity. We're doing that. and then we stop at negative 45 over 4. And you close off that with a bracket because we want to include that point. If you're struggling to see that, that's fine. Here's how we do it. You have negative 45 over 4. We know that's going to be included. Okay. We got to figure out which direction we're going, and so in this case we're going to go smaller. And that's how we can figure out, oh, it's all the way to negative infinity. So if you want, you can do the drawings first. That might help you too. Okay, so in the next case, notice we only have one fraction in this case, so we can multiply everything by 4 if you want to get rid of the fractions. So if we multiply every single term by 4, so you go 4 times 3/4 is less than 4 times the whole quantity, 5x minus 6, and that's less than or equal to 4 times 10. And so what does that make? Well, 4 times 3/4 is just 3, is less than, so that should be 20x minus 24, and that's less than or equal to 40. Okay, so now what can we do? Well, we can add 24 to all sides. And so you have to do it to every side. So you get 24 plus 3 is 27, is less than 20x, and that's less than or equal to 24 plus 40 is 64. And just so you can see what we did, on every single side we go plus 24, plus 24, plus 24. Okay, we do that to every single side. Now we divide every single side by 20. Okay, so in that case we'll get 27 over 20 is less than x, and that's less than or equal to 64 over 20. Now 64 over 20, there's an easy way. Both of those have factors of 4 in that case. So we can rewrite this as 27 over 20 is less than x is less than or equal to, it'd be 16 over 5. Okay, so the left-hand side is 1 point something. The right-hand side is going to be 3 point something. 3.2. In that case, we can actually set up our interval. So we don't want to include the left-hand side, the smaller of those. So we'll go 27 over 20. And then our right-hand side we do want to include. So when we put 16/5, we're going to include that. Okay. Questions on that piece? All right, so we'll move to a little bit harder inequality. And this one will involve a quadratic. And when we have quadratics, it gets a little bit more challenging in some regards. So the first thing is always, if you have a quadratic or some higher polynomial, get all the terms on one side. That's something a lot of people forget. So once you get this, you get a 0 on the other side, you're in good shape. And what we need to do is find what we call critical numbers. And what are those critical numbers? All we have to do is set that equation equal to 0. So x squared minus 7x minus 8 equals 0. And notice this thing factors nicely. We get x minus 8 and x plus 1 equals 0. So that means x equals 8 and negative 1. And the reason why that became 8 and negative 1, you go x minus 8 equals 0 and x plus 1 equals 0. Are here two equations you set equal to 0. Add 8 to both sides, you get x equals 8. And subtract 1 from both sides, you get x equals negative 1. That's where those two come from. So now what this allows us to do, there's a few different ways to do this. But first thing I like to do is draw a number line with those critical numbers. So you have negative 1 over here and 8 over here. Okay. And we know that when we plug that into x squared minus 7x minus 8, we get 0. And so these are the x values here. So notice we have different intervals. In our intervals of x values, we go from negative infinity to negative 1. We go from negative 1 to positive 8. And we go from 8 to infinity. And those are intervals we're going to test for solutions. And the way we're going to test, notice this thing factors nicely. It factors to x minus 8, x minus 1, right? Or x plus 1, my apologies. And then we had x minus 8 times x plus 1. And what we're going to do is we're going to test this to see if it's positive or negative. Because notice we want less than or equal to 0. So we want it to be negative values is what we're checking for. And we're going to test each interval. So we have negative infinity to negative 1 is going to be our first test interval. Our negative 1 to positive 8 will be our next test interval. And our 8 to infinity will be our final test interval. And what do I mean by that? When we have a test interval, you just pick a number inside it and plug it in and see if it's positive or negative. That's all we care about, positive or negative. So in our first one, we'll use, you have any choice in here, use x equals negative 10. Because that's in there. When we go negative 10 minus 8, notice we get a negative. Negative 10 plus 1, we get a negative. So then when we multiply two negatives, we get a positive for that. So that's greater than 0. So that's not going to work for our interval. In the second case, negative 1 to 8, let's pick the value 0. So use x equals 0. Okay, so when we plug that in, you get 0 minus 8, that's negative. 0 plus 1 is positive. Negative times a positive is a negative. So that's going to satisfy our condition. So what we can do actually right now, and since we have a quality at 0, we can shade those in. So far we have this centerpiece on our interval. It's going to work. And so for our final one, pick something from 8 to infinity. We'll use x equals 10, just for kicks. Okay. And so if that's the case, well, what happens? 10 minus 8 is positive. 10 plus 1 is positive. Positive times positive makes a positive. Okay. So in that case, we have all this gives for our solution is just the interval negative 1 to positive 8. Now, if it happened to be greater than 0, that's where you use the other two intervals and use a union symbol between them. But you can see how we use critical numbers and then find solutions and things like that. So hopefully that makes sense on that part. Okay. So now we're moving into some other sort of material. We want to start finding midpoints and things along those lines. So find the midpoint of the points 8, negative 3, and 6, 7. So if we have 8, negative 3, how do we find the midpoint? Well, the midpoint, the formula, if you have it goes x1 plus x2 over 2, and then y1 plus y2 all over 2. And then this is from points x1, y1 and x2, y2. Doesn't matter which one you call x1, y1. Doesn't matter as long as you have one of them being x and y coordinates, you're good to go. So in our case, notice here's what happens. We get 8 plus 6 divided by 2. And then we have, what's our next one? We have negative 3 plus 7 divided by 2. Okay, so 8 plus 6 is 14 divided by 2 is 7. Negative 3 plus 7 is 4 divided by 2 is actually 2. So you have 7, 2 is the midpoint, and you're done. In a similar manner, using x1, y1, and x2, y2, the distance formula in that case is the square root of x1 minus x2 squared plus y1 minus y2 squared. Now, you might be concerned in the order because we have subtraction here, but since we're squaring it, it always turns positive, so it shouldn't be a big deal. So in this case, what do we have? Well, we have this equals our x values, so we go 8 minus 6, the quantity squared, plus y1 minus y2, that's going to be negative 3 minus 7, the quantity squared. And so this distance equals, that's going to be 2 squared, which is 4, plus, that's going to be negative 10 squared, which is 100. So our distance equals the square root of 104. Or notice we can factor out a 4 from that, I believe. So you can write this as a square root of 4 times what? So it goes in twice. And we'll leave 24, so that means another 6 times. So 26, I believe. Okay. And so that means we can write that as square root of 4, square root of 26. And square root of 4 is 2. So you can write this as 2 times the square root of 26 if you want. That works out just fine. So now, using these two pieces, let's see if we can find the equation of a circle with diametrically opposite endpoints at 8, -3, and 6, 7. So the equation for a circle is x minus h squared plus y minus k squared equals r squared. So where h and k are the center, and r is the radius. Now the reason I chose this problem, I wanted to break it down so you could see each step. When you have 8, -3, and 6, 7, and notice that's what the same numbers we use for all these, right? So if I'm using different numbers, you got to go through different calculations, but I chose those same numbers just so you can see this all the way through. The midpoint is the center. So the center of this circle, so the center is 7, 2. So what that means is, first off, we have x minus 7 squared plus y minus 2 squared. And as of right now, we still don't know r, right? But we can figure that out in just a second. Notice our distance formula between those 2 points. We have the diameter, right? The distance is what we refer to if it's diametrically opposite. That means it's the diameter. Diameter equals 2 times the square root of 26, which equals 2 times the radius. Well, if you divide both sides times 2, that means r, which stands for our radius, should equal the square root of 26. So notice in our formula we have x minus 7 the quantity squared plus y minus 2 the quantity squared equals the square root of 26 squared. So what does this make? This makes x minus 7 the quantity squared plus y minus 2 the quantity squared equals 26. And you're done. Okay, moving forward from this point, let's work with another circle problem. And this one's going to be a little bit trickier. We're given an equation. We want to find the center and the radius of the circle. So this relates back to what we call completing the square. And so how do we complete the square? Well, we want to make this a perfect square inside here. So in order for us to make a perfect square, you want x squared plus, well, what's 6x? What we need to do is take half of this number and then square it. So we take half of that number, which is 3, and we square that. Okay? And the reason why we go about it that way, if you recall, a plus b squared equals a squared plus 2 times a times b plus b squared. Notice that extra 2 there means we've already factored in 2 times 3x, right? So our a is x and our b is 3, I should say. And so that means we're going to square that. But notice I can't just toss in a 3 squared. I have to subtract a 3 squared as well. Okay? So with that in mind, we'll do the same process for the y's. So the y's, to make a perfect square, we take y squared plus 8y. Now we take half of that term. What's half of 8? It's 4, and that's the number we're going to square. Okay, but we can't just add it in willy-nilly, so we'll subtract it over there. And that whole thing equals 75. Okay, so what does that allow us to do? And the whole purpose for setting up a perfect square here, just an FYI, remember we know formulas for x minus h squared plus y minus k squared equals r squared. So, and we're getting one step closer to that because the x squared plus 6x plus 3 squared, that is just x plus 3 the quantity squared. That's what we were doing there. And then We'll add the 3 squared over to the other side in a second. For the other one, though, we have y. Notice that's going to be plus 4 squared. Okay, and this should equal 75 plus 3 squared plus 4 squared. Notice that 3 squared is 9 and 4 squared is 16. 9 plus 16 is 25. 25 plus 75 makes 100. So we get x plus 3 squared plus y plus 4 squared equals 100. So this means the center, another way we can write this is x minus a negative 3 squared, if you don't like that, and this is y minus a negative 4 squared, and that equals 100 is just 10 squared, right? Or you can take the square root if you have a hard time figuring that out and leave that square root as is. So that means the center is at the point negative 3, negative 4, and the radius of our circle equals 10. And we're done. Okay, last but certainly not least, we want to find the equation of a line through the points, and so these are dealing with lines. Line through the points 17, 12, and 4, negative 14. Well, anytime you have 2 points and you want to find the equation for the line, oh, and let me see here. Maybe I can, there we go. Hopefully that can, so find the equation of a line through the points 17, 12, and 4, negative 14. Hopefully that you can view it a little bit better now and whatnot. But so if we're trying to find this line, what do we need to do? Well, you need to find the slope of those points. And the slope equation goes the change in y minus the change in x, or the way we do it is y2 minus y1 over x2 minus x1. In our case, if you notice our y2, you can pick either one, but we'll say it's negative 14 just for kicks. So negative 14 minus 12. That means, now here's the important part. If y2 was negative 14, that means y, or x2 has to be 4. So it goes 4 minus, and then in our case is 17. So notice that makes negative 26 over negative 13. And so that should be positive 2. So that's our slope. Now, you can use the slope-intercept form. What my suggestion would be, though, is go with the point-slope form, and then you can work it back to the slope-intercept form. Now, it doesn't matter which point you choose. I'd probably use the smaller numbers just to make it easier on myself, if it's me. So we can go y minus, if we use negative 14 equals m, so 2 times x minus x1, or x1 is 4 in that case. Notice I switched up what's x1 and x2. Please, actually, if you have a question, I'm happy to answer it, but you can even try the other one. Make sure you can simplify this down to the same thing. So notice this makes 2x minus 8, and this we'll have to, we'll take that negative 14. It becomes y plus 14, but we'll have to subtract it over to the other side. So what we get from here is y equals 2x minus 8, and then minus 14. And so y equals 2x minus 22. And notice I really didn't have to plug in and do some major multiplication other than multiplying the slope times each of those terms over on the right hand side. So hopefully that makes sense on that one. If not, let me know. I'm happy to help. Okay, so last but certainly not least, we want to find the slope of a line perpendicular to the line, 5x minus 8y equals 13. The trick to all these, if you have this, you solve for y and you'll get the slope pretty quickly. So notice we have negative 8y equals negative 5x minus, or plus 13. So now divide both sides by negative 8 with each term. So we can write this as y equals, you can write this as negative 5 over negative 8, and then we'll just leave the x out here to make it easier on ourselves, plus 13 over negative 8. And notice, excuse me, that is y equals 5/8 x minus 13 over 8. Which all we care about, though, is this part right here. what that means is the slope equals 5 over 8 for the original line. And we know there's a formula that tells us the slope of the perpendicular line should equal -1 divided by m. So that means our slope of perpendicular line goes -1 over, well, our m is 5/8, so this is 5/8. So what does that do? Well, remember, keep it, change it, flip it. We keep the numerator, so you still have the -1, times, because we're changing that division to multiplication, and then flip it. So you flip that denominator, so it becomes 8/5. So keep it, change it, flip it. So notice that equals -8/5. And we are done. That is the slope of our perpendicular line. And if you had to create an equation from there, that's all you'd have to do is just plug in the slope, plug in a point, and you're good to go. So I don't see any questions for the rest of it. Sorry about the little hiccup in terms of my computer kind of freezing on me. It happens from time to time if there's too much going on in terms of streaming at the university here. So if you have any questions, though, please don't hesitate to ask. There's plenty of discussion boards and things like that. There's a YouTube live discussion board. So please ask away. That's what I'm here for. I hope you all have the best of exam time and have some fun when that comes around.